Welcome to Get Your FRQ On. This question is from 2003. It's question 6, and it is not calculator active. In the question stem, we are given a piecewise function defined on the interval from 0 to 5, and in part A, we are asked to determine if this function is continuous at x equals 3 and to provide an explanation. Well, in order for f to be continuous at x equals 3, all we really have to show is that the limit as x approaches 3 from the left is equal to the limit as x approaches 3 on the right, that those two limits are the same, and that the actual value of f of 3 is the value of that limit. So we need to show that the limit as x approaches 3 from the left of f of x equals the limit as x approaches 3 from the right of f of x equals some real number L, and then we have to show that f of 3 is that same value of L. All right, so it doesn't take too much work to show that the limit as x approaches 3 from the left of f of x and the limit as x approaches 3 from the right of f of x are both 2. We do get to plug in 3 for x in the top half of this function. 3 plus 1 is 4. The square root of 4 is 2. So as we get closer and closer to 3, that's going to get closer and closer to 2. For the bottom part of this function, if x is approaching 3 from the right, we are also approaching 2 from underneath, the lower side of 2, so 1.99 and so on. And since I already talked about this, if we plug in 3 into the top half, which is the half of the piecewise function that includes 3 in its domain, we do in fact get f of 3 to equal 2. So yes, f of x is continuous at x equals 3. All right, find the average value of f of x on the interval from 0 to 5. Now by definition, the average value of f of x on this interval is an integral. It's 1/5 the integral from 0 to 5 of f of x dx, which we can split. In fact, we need to. We can split that into two integrals, 1/5 the integral from 0 to 3 of f of x dx, plus 1/5 the integral from 3 to 5 of f of x dx. Now, what's interesting here is in order to do this integral, because it's a piecewise function, we had to show it was continuous first. Right? Continuity implies integrability. So our work in part A justifies this question. The function is continuous at x equals 3, so the expression on the left, the integral from 0 to 5 of f of x dx, does make sense. Right? It is a continuous function on that interval, so we can actually talk about that integral. If it had a discontinuity, all sorts of weird things could happen. All right, so we want to calculate these two integrals on the right separately. All right, so we have 1/5 the integral from 0 to 3 of square root of x dx, plus 1/5 the integral from 3 to 5 of 5 minus x dx. Those are some pretty straightforward integrals to find. Do the antiderivatives, find those, and then evaluate at those endpoints. There is a little bit of math here to do, but at some point you're going to be able to stop. I simplified it all the way. You don't need to do that in a free response question. Just the expression on the left would be okay, provided it's correct. It does ultimately reduce down to 4/3. In part C of this question, we are defining a second function, g of x, which is a constant k times the square root of x plus 1, and a linear function mx plus 2. We are given that g is differentiable at x equals 3. That's not something we have to show, that's something we are given. And the task is to find the values of k and m that satisfy these conditions. G is defined in terms of k and m, and given the fact that g of x is differentiable at x equals 3. All right, so if g of x is defined as above, then the derivative of g we can just find again as a separate piecewise function. That's going to be k over 2 times x plus 1 to the minus 1/2. And since the bottom part of this piecewise function is just a linear function, g prime is just going to be m for all of those values. However, we're given that g is differentiable at x equals 3, so we know that g of x is continuous at x equals 3 because differentiability implies continuity. Therefore, we know that 2k equals 3m plus 2. All right, that's just plugging in the value of 3 into both parts of that function. If 3 is x in the top part, we get 2 times k. If x is 3 in the bottom part, we get 3m plus 2. It's differentiable, so those two have to be the same. All right, if I look at the limit as x approaches 3 from the left of g prime of x, that's going to get me k over 4. And if I look at the limit as x approaches 3 from the right of g prime of x, that's going to get me m. Now, since g is differentiable at x equals 3, those two expressions must be equal. All right, so we have the equation k over 4 equals m. That's just some simple algebra. We already know 2k equals 3m plus 2, and we have k equals 4m. That leaves us with 8m equals 3m plus 2. Solving that equation, we get 5m equals 2, so m is 2/5. And then we can use that information to solve for k. K is 8/5.